identify subgroups in readmitted patients, implications for precision medicine. This webinar series is coordinated by the Aging Initiative, which is an NIA-funded initiative that bridges the expertise and leadership of two powerhouses for research on multiple chronic conditions. The two powerhouses are the Healthcare Systems Research Network and the Claude D. Older Americans Centers, or Pepper Centers. The Aging Initiative is led by Dr. Jerry Gurwitz at University of Massachusetts and Myers Primary Care Institute, along with co-PIs Elise Adams and Jay Magaziner. My name is Heather Whitson. I'm an Associate Professor of Medicine and Ophthalmology and the Deputy Director of the Duke Aging Center, and I'm part of the Aging Initiative Dissemination Workgroup, which is co-led by Leah Hanson at HealthPartners. So before we get started, there's a few technical details I'm going to cover. Because of all of the registrants for today's webinar, we have phone lines placed on mute to reduce our audio feedback, although it sounds like today we're getting a little bit extra. So unless you're logged in as a host or panelist, your line is already muted. And if you are a host or panelist, I would also ask you to mute your line when you're not presenting. But we do welcome and encourage audience participation using the Q&A and the chat features of the webinar software. So if you are in your Cisco webinar portal, you can look at the row of circles across the bottom center of your screen. And if you click on the chat bubble icon, it will be highlighted in blue. And then if you have questions for our speakers, you can click on the Q&A tab on the right side of the screen and then be able to type into a Q&A box. Leah and I keep an eye out for those questions under the Q&A icon, and as time permits, we'll read the questions later for our speaker after the presentation. If you have technical or logistical concerns or questions, try to submit those using the chat box, which is above the Q&A box, and make sure that you're identified either by your name or your participant ID so that the webinar hosts will be able to help troubleshoot the problem that you're having. And with the chat function, you can choose whether you would like your comment to be visible to all participants, or you can send the question only to the hosts. I want to extend a huge thanks to those hosts. So Catherine Anzoni and Chris DeLude are both at the Myers Primary Care Institute, and they do amazing work behind the scenes to make these webinars possible. They'll be monitoring the chat functions today to help with any technical troubleshooting. Now, I'd like to introduce our speakers. Our first speaker is Dr. Suresh Bhavnani. He's a professor of biomedical informatics at the University of Texas Medical Branch. He obtained a PhD in computational design and human-computer interaction from Carnegie Mellon University and specializes in visualization and analysis of large biomedical data sets with applications to clinical and research decision support. Funded by PCORI, NIH, and NSF, his pioneering research in the use of bipartite networks to identify patient heterogeneity in big biomedical data has received 5 distinguished paper awards from international organizations such as the American Medical Informatics Association. After Dr. Bhavnani speaks to us, we'll hear from Dr. Timothy Reistetter, who is a professor and associate dean for research in the School of Health Professions at the University of Texas Health Sciences Center in San Antonio. He is widely recognized for his leadership in health services research within rehabilitation in general and in occupational therapy specifically. Through his K-12, K-01, and subsequently his currently funded AHRQ R01, he has brought the discussion of how to measure rehabilitation geographic regions to the forefront. His current research in identifying heterogeneity in readmitted stroke patients is being used to design and evaluate precision medicine approaches for stroke self-management. So I want to thank both of our speakers, and with this, I will turn it over to Dr. Bhavnani, and hopefully you will also be receiving control of the slides.
Thank you so much. Can everyone see my slides?
Not yet. I think you just have to share button.
I got a message saying that I'm now the presenter.
Yeah, you just have to go to the top left and click Share Your Screen, and that should be all set. perfect.
How do I get rid of this? Okay, thank you so much. Can everyone hear me? Okay, we turned down the fan here. I hope that has helped.
Yep, it sounds good.
Okay, excellent. So thanks so much to the Aging Institute for funding this pilot study. The research here at UTMB was conducted by myself, Co-PI Yongfeng Kuo, who's Professor and Director of Office of Biostatistics here, and Laurel Copeland, who provided the data from the Veterans Administration. And this research could not have been done without the collaboration between the OAIC and the HCSRN. So thank you very much. I'll begin with our motivation for analyzing 30-day hospital readmission in total hip knee arthroplasty patients. I'll present how we extracted data from the VA, our visual analytical method and the results, and then conclude with implications for precision medicine and predictive modeling. As many of you already know, there's been a steady increase in the number of hip and knee arthroplasty in the elderly population. In 2010 alone, there were 1.6 million arthroplasties and 3.2 hip arthroplasties and 3.2 million knee arthroplasties, and these have subsequently increased. Now, despite the successful procedures on these patients, 6.3% of these patients have unplanned hospital readmissions. These readmissions lead to avoidable mortality, morbidity, and resource consumption. What is not as well known is that the current models to predict patient-specific hospital readmission have only marginal predictive accuracy. Currently, the logistic regression models have a C-statistic that range from 0.6 to 0.65. So there's definitely room for improvement. And one of the reasons that we believe that such models have not been able to achieve higher predictive accuracy is because they do not consider patient subgroups, which could improve that accuracy. Now, why are patient subgroups important? Well, numerous studies on topics ranging from molecular to environmental determinants of health show that most humans share characteristics forming patient subgroups, and a primary goal of precision medicine is to identify these patient subgroups, infer and validate their underlying causal processes, and then ultimately to design interventions that are targeted to those specific patient subgroups and hopefully to improve their outcomes. Now, there have been three basic approaches that have been used to analyze the risk of readmission. The first is very simple, univariable descriptive statistics. For example, you identify the risk of readmission with renal failure to be 1.3. However, this approach cannot reveal how comorbidities interact. The second is multivariable predictive modeling, such as logistic regression. And such models provide you coefficients for different variables, but such models cannot reveal patient subgroups, which we already discussed are quite important for precision medicine. And then you have combinatorial methods like taking every pair, every triple, etc. But such combinatorial methods, besides leading to a combinatorial explosion, cannot reveal interactions among such combinations. So what is missing in these approaches, as I have already alluded? None of these methods have focused on patient subgroups, which is critical for precision medicine. And so we began our research by posing the question, how do patient characteristics co-occur across subgroups of readmitted patients? And we focused on total hip arthroplasty and total knee arthroplasty, which is a model that CMS has developed to predict readmission because such patients have a high risk for a 30-day hospital readmission. In collaboration with Laurel Copeland, we got access to a ton of data from the Veterans Affairs Clinical Data Set, which represents about 130 medical centers in the U.S. Our data inclusion criteria included 100% of hip and knee arthroplasty patients readmitted within 30 days of hospital discharge. We excluded all patients under 65 years because we wanted to focus on the elderly, those who died during hospital stay and had missing data for date of birth and age. Controls were equal number of patients not readmitted within 30 days, matched by age, gender, and race. And this was the overall numbers at each stage of the inclusion and exclusion criteria. We focused on all comorbidities from the Charlson and CMS-CC indices that were also in the VA-CDW, in addition to vitals, marital status, and frailty, which our stakeholders advised us to include as patient characteristics for our modeling. All of this resulted in 460 matched pairs, each in the training data set and in the replication data set. And the knee arthroplasty, we had 895 matched pairs, each in the training data set and in the replication data set. Characteristics resulted in 47 variables, and they were of different data types. 41 were binary, 1 categorical, and 5 continuous. These data, as I said earlier, were provided by Dr. Copeland, who was a co-PI. Now, next, we had to select features to include in the modeling. So we used logistic regression to estimate the significance of each variable for predicting readmission in each data set and corrected for multiple testing. Next, we selected the top 10 in the training data set that were also highly ranked in the replication data set. Why did we pick top 10? Our research in visual analytics in the past has guided us to a simple fact that domain experts tend to prefer between 10 to 15 important variables when trying to comprehend results from biclustering, as I will show you shortly. Now, clustering methods require uniform ranges and meanings because ultimately clustering methods use Euclidean distance to show similarity. And so given that our data set had varying multiple data types, we transformed the value of each variable for each patient into the respective univariable probability ranging from 0 to 1 for predicting readmission. Intuitively, you can think of the spreadsheet as having rows that represent patients, columns that represent your variables of different data types, and each cell is your data value, but those are of different data types. And so this approach that we use basically asks the question, for example, what is a patient's probability of readmission based on age alone? Let's say you're taking the first variable, which might be age. And so now you get a predictive probability, a univariable predictive probability that ranges from 0 to 1. And in that way, we range normalize the entire data set in this process. Why are we doing this? We're doing this because if we want to do clustering of multi-omics data, we need a way of transforming multiple data types into a uniform range that can be used for the clustering, as well as important for the interpretation of the results. Next, because we were using a matched case control design, one-to-one, overall readmission probability is, of course, 0.5. And so the probabilities that I just described to you were therefore dichotomized for the bipartite network analysis. So now we are left with binary values that represent these predictive, that were generated originally from the predictive probability. I know this might be a little bit very mathematical and complex, but I can, answer questions. But this is the core of the contribution for this particular pilot study, and so I'd like to emphasize that point because most of clustering tends to be unipartite, but when you're doing bipartite clustering, this transformation is what has been missing. And so we've been stuck with either doing all binary modeling or continuous, but this approach, we are mixing multiple data types, and it sets us up for the multi-omics revolution that's currently happening. So this resulted in the hip arthroplasty patients. We had these 10 variables that survived this whole process. In total knee arthroplasty, we had another 10, and 6 of these overlapped, demonstrating how both of these conditions are quite similar in terms of the crucial variables that predict readmission, but also a few different ones. So at this point, this is in data mining, this is what we call feature selection. And so the next step is to take these features that are important for each of these conditions for the outcome of hospital readmission, and we're going to then explore how those form patient subgroups, and that's what I'm moving on to next. So we use networks. What is a network? A network is a set of nodes connected in pairs by edges. So what you're seeing on the screen right now is what's called a unipartite network. This is what Facebook uses to identify communities, which then they observe and then target with ads. But when I initially started using this representation for biomedical research, I didn't find it very useful because what's critical in biomedical informatics and biomedical research in general is not just how people are similar, but why. And that led me to explore another graph representation from graph theory called a bipartite network. A bipartite network has two types of nodes, as you can see, a patient node and a characteristic node, and an edge that connects both of them describes the association between a patient and characteristic pair. What's the advantage of this representation? Well, using this representation, you can identify quantitatively as well as visually patient subgroups and the characteristics that frequently co-occur with them. So as you can see here, even in a very small data set, the red nodes represent the patients, the triangles represent characteristics, and the edge here, the predictive probability, which we are using. It doesn't have to be a predictive probability. It could be just binary, but this is how we were using it for the current data set. Now, what you can see here is the patient subgroup on the left is pretty homogeneous. They all have cellulitis and nothing else. But on the right-hand side, you can see that the patient subgroup is fairly heterogeneous. One just has gait disorder, another one has peripheral vascular disease, and three have both of those plus cellulitis in another cluster. And so the bipartite representation shows you the complexity of heterogeneity in the data, which I found extremely attractive for biomedical research when I started using networks. Along with this visual representation are methods to quantitatively characterize the data. So you have the notion of the degree of clusteredness, which essentially means how separated these patient subgroups with their characteristics are, and that's there's mathematics underneath that. The fraction of edges falling within a cluster minus the expected fraction of such edges in a network of the same size with randomly assigned edges. Intuitively, it's basically saying you have more edges within each cluster compared to between. And that is a quantitative measure of describing how tightly clustered your data is. Now, many clustering methods do not have this measure. The power of this measure is that you can now calculate its significance. And so what we do is we take the data and randomly permute it 1,000 times. And for each of those 1,000 times, we calculate this modularity measure. And so now you have a distribution of random modularities. And now you can test how many standard deviations the real modularity is from this random modularity. And so you can now test a fairly complex phenomenon of clustering in your data by a single measure. And that's what the network analysis, and in this case, the bipartite modularity provides you, and you can analyze thousands of patients, so because it's optimized, the search is optimized for very large data sets. In addition to that, you have measures of replication called the RAND index, where we take another data set, or it could be a split half of your full data set, and now you can count how many of these variables are in the same cluster in both data sets, and how many are in different, and that becomes your numerator, and your denominator is all the pairs. So it's a proportion of similarity in the clustering of your characteristic. I wish you guys were in the room so I could see whether you're nodding your heads or totally confused, but I'm trying my best to express these measures, which are very cool, and they work because we've tried them on many different data sets. So I'm going to go on. If I'm looking around the room here, and people are nodding their heads, so I'm hoping this is understood. Okay, but when we have large data sets, especially bipartite networks, they tend to become a hairball. You can't see these clusters. So I developed another algorithm called the explode layout algorithm that identifies through modularity these patient subgroups and then visually yanks them apart using this very simple approach called explode layout. We find the centroids of each of these clusters, generate a circle, pull each of these to the circumference of that circle, rotate them to preserve their original orientation to each other, and then you have your clusters. So we use that. So the results were very promising. The total hip arthroplasty showed 7 biclusters with strong and significant degree of clusteredness. Q stands for the modularity measure that I just described. 0.35 is quite high. 0 is random. 0.30, most real-world networks are in the range of 0.3 of modularity, so we have quite strong degree of clusteredness, and it was significant compared to 1,000 random permutations of the network, and we also got strong and significant replication based on the RAND index in terms of the pattern of co-occurrence of these variables. Total knee arthroplasty had 6 clusters, which were also strong and significant, and had strong and significant replication. So after all of that analysis, we were quite encouraged by these results. Now, 6 of the variables were shared between both of these, and so we got the stakeholders into the room. We showed them these networks. There was a discussion on what it means in terms of hospital readmission, and so all that resulted with interesting implications. The clinician stakeholders noted that majority of the patient characteristics that survived the feature selection were comorbidities, with the exception of BMI and opioid usage. These results agree with observations in other studies. Other studies have shown that readmission in hip and knee arthroplasty tends to be for non-surgical reasons, suggesting existing comorbidities are associated with a high risk of 30-day readmission. They went further to infer what might be the cause of the hospital readmission when such patients are discharged to the community, for example, to a skilled nursing facility. And this kind of captures their inference. These are all hypotheses, but it's interesting that the visual analytics enable them to start thinking deeply about what might be going on in such patients. So the patient is admitted to the hospital for hip or knee arthroplasty. When the patient is discharged, typically the physician writes hip fracture in the discharge notes. This information goes to the rehab facility, and they tend to focus on wound healing and physical therapy. My mother went through this process, and the next morning she said, get out of bed, get into PT, right? You can't sleep anymore. But what is happening is that a patient like my mother is in a new environment. All the focus is on wound healing and physical therapy. What is not being observed is the reduced oral intake, increased bed rest. It tends to impact dehydration and poor nutrition. There's a lot of literature on this, which the domain experts provided to us. I haven't put it here, but it's in a publication that we have put together. And this dehydration and poor nutrition may be triggering existing comorbidities, resulting in a hospital readmission. Now, in the discussion with the stakeholders, they hypothesized that we could break this cycle of readmission by changing what information is transmitted in the discharge summary. So, for example, the patient came in for total hip arthroplasty and has psychological comorbidities and is on opioids, which was one of the clusters that we identified. When this patient goes to a rehab facility, there's targeted interventions, maybe through order sets, that focus on that instead of just focusing on wound healing and physical therapy. This could guide triaging and monitoring of those comorbidities, leading to early identification and treatment of exacerbation and reducing the risk for hospital readmission. So when we presented this inferred causal model, of course it was inferred from the associations that we see in the clusters. When we presented this to the UTMB hospital, they got really excited. They said, we don't have a protocol in place currently of information being communicated between UTMB and the SNFs, and SNFs do have a lot of readmissions. Why don't we try this? Right? Why don't we just try? This is low-hanging fruit. We don't need any clinical trials or anything to test this. Let's just make sure that we transmit high-risk comorbidities, variables, etc., in the discharge notes, which could then impact what is being focused on with the patients, in addition to the wound healing and physical therapy. And so the implications is to improve discharge notes and also to train providers to focus on these comorbidities, which appear to not be focused on at this time, because the focus tends to be only on PT and wound healing for hip and knee arthroplasty. The identification of these patient subgroups, we proposed to PCORI, and we basically argued that these automatically identified patient subgroups could be used to develop stratified regression models, which we have been doing. And the results are very interesting, but outside the scope of today's discussion. But essentially, we're taking those patient subgroups, developing classifiers so that new patients can be put into one of these patient subgroups, and then instead of having a lumped regression model, we use targeted regression models for each of those patient subgroups to predict whether the patient would be readmitted or not. So in conclusion, we have experimented with a visual analytical method to obtain an integrated understanding of patient subgroups and the co-occurring factors that are predictive of an outcome, in this case, readmission. And the specific approach that we added in this pilot was to address the multiple data types, which appears to have worked. Implications were for precision medicine, as I just described, and predictive modeling. And our current and future research includes testing the generality of the methodology and other outcomes in the VA data. We have a publication in review that focuses on modeling multiple data types in bipartite networks. And the same approach will be, hopefully, if I can make the deadline on June 5th, an R01, which, to identify symptom clusters. So we're not, the FOA wants us to look at symptom clusters, and that's what we're going to use it for. And I think I'm done. Thanks for your patience. I hope everyone is still awake. Maybe I can handle questions now or later. It's up to you, Chris. Over to you.
Yeah, I think we're good to start with questions. So you can begin submitting questions as they come up, and I'll bring up the instructions now.
So should I get out of my slides?
I'll change the permissions now. One moment.
Yeah, so Tim will be on.
Hi, this is Heather. Sorry, I think I was on mute before. Is it okay if I read you a question?
Oh, yes, go ahead.
Great. Okay. We do have a question that's been submitted, and I'll also encourage others, if they would like to submit a question, that they can do so through the question function. Let me just, I had it up here a second ago. Okay. Sure. Dr. Green says, very interesting presentation. Given that these methods are very sophisticated and that many clinical end users may not have the specialized expertise to replicate these analyses, I appreciate that you incorporated the more pragmatic and accessible model. So the question is, can you talk about how this might be scaled and implemented more widely for community-based health systems or skilled nursing facilities that might want to pursue a similar analysis?
So the Explode layout algorithm has been made public. That is very crucial for people understanding, the clusters. So that is all written in R, and it's publicly available. You can download the code and use it. Of course, you need to know how to program in R. So, and then the rest of the analysis, the method, PCORI requires all that code to be public, and so that is also going to be public. But I don't think it's kind of something that people without our programming would be able to do. You need a programmer or an analyst, and many analysts that you can hire in informatics, they know how to run such programs, publicly available code. We are exploring putting together a company to sell software with an interface, but who knows how that would happen. That's a long shot. But the university wants our code to be more easily usable using an interface, which I would love to do because my background is in human-computer interaction. I don't know if that answers the question.
I think that does answer the question. Yeah, thank you.
Okay.
And I think I would say that's probably a similar issue that comes up in sort of big data science is it's a very powerful tool, but you really have to have someone who's trained to use it.
Yep.
Mm-hmm. Great. All right. Well, with that, I think if you'll hang around, there may be more questions for you after our next talk.
Yeah, but I have a question myself.
Yeah, sure.
Did I lose people? I mean, I was trying really hard to be clear and sort of provide intuition. It's easier if you can see me, but use my hands. But was it clear enough for?
I thought it was incredibly clear. Yes, I did. And actually, at one point during your lecture, when you asked the question, I tried to answer, but I was on mute. No, I think it was clear, and it is one of the challenges of this format, since many of the other people who are listening don't have the option of unmuting themselves. So I think they would also tell you that you made a very sophisticated topic as clear as it possibly can be to non-experts.
Okay, excellent, because that's a relief, because I really want people not to be intimidated by all of this, but really to get the basic point that you need methods that integrate visualization that is intuitive, as well as the mathematics, the quantitative part and the significance. And over the last few years, we've been able to tightly integrate both of those worlds in our modeling. And it's very interesting when the stakeholders come into the room, and PCORI is big on making sure stakeholders are engaged at every step of the process. And when we get the stakeholders into the room, we have nurses, we have geriatricians, we have gerontologists, we have statisticians, we have everyone in the room in the focus group, and then we bring up the visualization as well as some of the numbers. It's fascinating how the room just erupts with comprehension of what's going on, and that's fulfilling because I'm not a domain expert, right? I'm the informatician, and it's very fulfilling for me to see domain experts, or the stakeholders as we call them today, sort of go past the modeling, which, like regression and other things, tend to be very like black boxes. But when they see these the visual analytics, they immediately understand what's going on, and they're jumping into their domain expertise and moving quickly to the possible causal mechanisms in each of the subgroups. Now, remember, I'm not just doing clinical data. I'm also doing genes and protein. All of that stuff is also happening in the lab. And in there, those are the pathways. Here, they're thinking about why would someone come back with these particular comorbidities. Anyway, I'm sorry, I'm getting too excited, but I just wanted to express to you that it's not just analysis, but it's really engaging the team in comprehending what the heck is going on, resulting in the outcome. Anyway, I'll stop talking now. Is that good?
Yes, no, that's very helpful, and we did get a comment in thanks to your previous answer, and the commenter also noted that she hopes someday that we will get to the point, though, where these models are reliable enough that they may be able to be in use in places that don't have our programmers available on the ground, given resource constraints and competing demands. And, you know, I sort of I imagine that it does feel like this is sort of still sort of so cutting edge and new, but I imagine that at some point back in history, you know, maybe regression felt that way, or you know, and now you can sort of point and click your way through it, perhaps at your own risk. But
absolutely, we're still working through, you know, all of these different issues. There's another dimension that's involved in all of this. Is, you know, before I came into informatics, I was studying architecture design, and I got a very solid grounding on you know, the visual dimension. And so a big part of the visualizations that I create is also tapping into color theory and shape and form. And so, you know, all of that is also incorporated, which I'm not talking about, but it's something that's very important when you design. You actually have to design these representations. They're not just things that come automatically, you know.
Right.
So many degrees of freedom that are involved. And so there is cognition, there is visual, you know, graphic design, and the biostatistics, and of course data mining, all coming together. Anyway, let's go on to the next.
Understood. Yes. So and I think Chris will need to pass off control again, and then Dr. Reistetter, can you let us know when you have the ability to share your screen?
We are ready. So now we have to click on something, I suppose. Okay. Okay. Can everyone see the slides?
Yeah. Yes, they're up. Thanks.
All right. Good afternoon. Again, my name is Tim Reistetter, and I am going to give you a clinician's perspective on how to utilize this information. So Suresh has done a good job of giving you the breadth of everything that goes on. We will show here the implementation of that and how we use that clinically. And as was mentioned in the bio, my preferred clinical area is adult neuro rehabilitation. So I've done a lot of work in stroke rehabilitation, and so that is the area that we're going to spend a little bit of time in. So for those of you that I assume everyone has some understanding of stroke, but I wanted to give some basic information. Stroke is the leading cause of disability and institutionalization and readmission. Almost 800,000 Americans sustain a stroke each year. And many of the stroke survivors face substantial disease management issues. And these hurdles make living within the community a very difficult transition for them, and it makes it very difficult for them to participate in activities that are meaningful to them. These post-acute hurdles lead to a lot of different issues that we hope to alleviate during the rehabilitation process. And so this idea of how do we manage stroke, and how do we come up with situations and programs that are going to help our clients manage their conditions, led to the development of a stroke multidisciplinary translational team here at UTMB. It's actually supported by our CTSA, and the project goal is to inform the development and implementation of a stroke-tailored chronic disease self-management program for individuals that are living in the community. And so our stroke team, it's rather big, but we bring together a series of different experts that have information in a variety of different areas. So we leverage our experience in large data, both health services data as well as visual analytics, as Dr. Bhavnani has mentioned. We also bring together considerable amount of work and expertise in patient-centered stakeholder engagement. We have a patient-centered outcomes research center here, and one of the main projects in it is stroke, but we have others as well. And these experts bring together the capacity to do mixed method designs to really inform both our data analyses, but as well as our interventions. So, and that leads to considerable clinical expertise and trials in those areas. So I wanted to get in a little bit to the data, and again, it's going to align with what Dr. Bhavnani has described already. But one of the distinctions and differences here with our stroke study is that we're using Medicare data. So we have a considerable amount of Medicare data here on campus, and for this analysis, we used data, 100% data from 2013 and 2014. So we combined a few Medicare data sets, the MedPAR file, which contains medical records, so that would have all the acute care records, and it also would in fact have all the post-acute care records as well, so where someone went after their index stroke and on down the line. And we also linked with that the master beneficiary file, which gives us some demographic information about the individuals that are contained within the records. So in our initial cohort, what we were looking for and what we identified within these data are records of individuals who had sustained a stroke in 2013 or 14. And for our study, we used just their initial discharge placement. For the analysis, we also limited it to individuals 66 or over at admission. Although a lot of people think the Medicare record is just older adults, there is a smaller group of people that receive services due to other disabilities, and they're within here as well. We also used a variety of other exclusion criteria that are pretty standard for any version of health services research using Medicare data, so we limited it to Part A coverage only, and that's really so that we don't lose that individual over the course of time if they move in and out of different types of service. We excluded individuals that were transferred to another acute care facility. This is because our outcome of interest is readmission. We want to make sure we get that correct. And then we excluded individuals that were discharged against medical devices or medical advice. So that leads to both a training and a replication data set that's shown here, over 200,000 in each data set. So as far as patient and variable selection, Dr. Bhavnani did a real good job of talking about how the training set and replication sets work. I would just point out that our training data set and our replication data sets are listed here by size. The thing that I think is probably most important for you to understand in terms of what we did for our study in stroke is this idea of how we analyzed our comorbidities. And so we captured by looking back over the year all the comorbidities that the individual had listed in those records. And then we used a variety of different mechanisms, similar to what Dr. Bhavnani did with the readmission measure specifications that CMS put out, as well as Elix-Hauser and Charleston indices to identify the frequently occurring comorbidities. So that group initially started at 96, and then through stakeholder interactions, as well as some statistical approaches, we eventually whittled that number down to the 72 significant comorbidities. So we then fed it into Dr. Bhavnani's system, and we ended up with 5 Biclusters that represent individuals that were readmitted for stroke. And again, in our analysis, where we have both individuals that did readmit as well as those that didn't in order to calculate these. So our clusters, as with the other approach that Dr. Bhavnani described, had strong amounts of clusteredness and were significant. And we use these clusters to inform our self-management program from a clinical perspective. And so I will get into it in a minute, but we are in the process of implementing a feasibility trial right now using a self-management program that's evidence-based and published. And each of our clusters here represent different combinations of comorbidities. And as I get into the discussions of each of the program we're using, I would just like to point out that what we did, in essence, was take all the individuals that are in the blue cluster at the top, and we used a method within our self-management program to incorporate that within session 2 of our session. So each of the clusters are utilized within a case vignette within each of our different self-management sessions. So the self-management program we used is a very widely known program. It's out of Stanford. It's referred to by some as the Lorig model. So it's a chronic disease self-management program that's designed to improve quality of life and improve psychosocial function and increase confidence in somebody's ability to manage their chronic diseases. It does have within it information about a group of chronic conditions that are common. Each of these are taught in a fairly standard educational format. The programs cover a range of topics. There are techniques that deal with problems such as frustration and fatigue and pain. There's also some that deal with exercise and flexibility and endurance. There's a chapter that covers medication management and communication with family and healthcare workers, as well as nutrition, and then how to access community resources. So this is what the standard program from Stanford has in it. And in the training process, individuals would go through, or in the self-management program, they would go through each of these different modules. There have been a variety of studies done with this chronic disease self-management program. There's a good review. It's at the top of the screen by Kate Lorick, talking about insights from using the program. I also highlight one that's recent that's in stroke. It's actually in topics in stroke. It's by Dr. Wolf and group. And they actually used this chronic disease self-management program with mild stroke in a controlled trial. And they had two what I thought were very interesting comments within the program. So the program does have some benefit. They had some challenges as well. And what they said in there is quoted on the right: individuals with stroke may have several chronic symptoms or chronic conditions, not just one. So, if we're just going to deal with communication or nutrition, we might want to talk about communication and nutrition. And then the linchpin that definitely validated our desire to go do this is that future studies should explore self-management programs that are more tailored. And they were specifically talking about for mild stroke. But you need to tailor it to the individuals and the groups that you're dealing with. And so what we have employed here in our early phases is a tailored stroke-specific program. And our hope really is to bridge this gap between the evidence-based approach and what really happens for our patients. So we know that the majority of our patients have a considerable number of chronic conditions and comorbidities that they're dealing with. They're not just dealing with the ones that they just acquired from their stroke. There's some that they've had for quite a long time, and these collectively have a negative impact on outcomes, be it functional status, be it community mobility, be it cognition, be it the ability to participate and play with your grandkids. So lots of implications. And so we are using the visual analytics, the clusters, and what the comorbidities are within those clusters to inform a component of our self-management program. And I'll talk a little bit more about how we do that in a minute. So our self-management program contains 6 sessions. It's consistent with the core components of the Stanford LORIC model. We have an introduction followed by a series of sessions. And again, within each of these sessions is our implementation and adaptation, where we're using a vignette story of an individual with multiple chronic conditions. So I said at the beginning, the blue circle at the top of the cluster figure was in session 2. So we walk through our 6 sessions and present these case vignettes as educational tools as well as activities to help the participants consider possibilities and consider how one might manage these conditions. So again, we put these within our course. What's in red here is one of the vignettes. It's a short snippet of it. All of our vignettes are around a 3/4 of a page to a page. But this vignette example here, how would you advise Miss Smith, age 72, who has had a stroke but also suffers from coronary artery disease, high blood pressure, morbid obesity, and congestive heart failure? So these specific conditions actually align with the pink or red cluster that's in the visual analytics. And so the way we employ this, on top of the educational session, the way the evidence-based, or the way our program is set up for each of the conditions, at the end of that session, we use these vignettes. So this has a couple advantages. One is the individuals are considering a situation for someone else. So it allows for a lot of interaction and dialogue about how one might manage chronic conditions. And in that way, it's slightly less threatening and allows them to consider how these might work. And what ends up happening in this type of discussion is that individuals bring forth other ideas relative to themselves. They also get to spend time considering how to handle chronic conditions. So some of these ideas, if they're talking about increasing exercise and the individual also has issues cardiovascularly or metabolically, they all interplay with one another. And using these sorts of case vignettes, again, informed by the visual analytics, allows us to broach those topics and to help people consider and come up with solutions. So our self-management feasibility study that we currently have going is being tested at multiple levels. So we are interested at the patient's level. How feasible is this program? Are they, from a self-efficacy standpoint, do they feel like they could do this? We're also interested in this from an implementation standpoint at the institution level. So is the institution ready for this? Can we employ it? Similarly, we do have some secondary outcomes that we're looking at and exploring. The Southampton Stroke Self-Efficacy Questionnaire. We have a series of promise measures here that we're also including to better understand the implications of this program on outcomes. This slide actually gives you a representation of our trial itself. So the graphic here shows if an individual has a stroke and they're in an acute setting in our hospital, we would approach and consent them and take baseline measures, which would include the health distress questionnaire, which is a very common one used with this Stanford Lorick model, as well as these other promise measures. They would then get provided the standard education materials at discharge, which a lot of our materials are paper in origin. As part of our program here at UTMB, there's a 90-day follow-up visit that's standard of care, and part of the process, we would at that point approach them to see if we about randomization. So we take our baseline information again at that point and put them in either the standard care group or the self-management group, which we would then execute. So our sessions, again, consistent with the evidence-based model, are an hour and a half long over a 6-week window, again, informed by the visual analytics through the vignette. And our basic inclusion criteria here, again, it is a feasibility trial at this point, is at least one chronic medical condition, able to consent and able to participate. So that is all I have. I'm ending with a slide here that I am certain is missing some key key individuals from our CTSA or our PEPR. We have obviously many people involved in this project, and I just wanted to give some accolades. This is in many ways the core group that's been very active most recently with the development of our feasibility trial.
Hey, my name is missing.
Yeah, look at that. So anyway, at this time I can entertain some questions and see where we go from there.
Sorry, I'm taking myself off about 3 mute buttons. Thank you. I want to thank both of our presenters for outstanding talks, and remind folks that if anybody has questions, that they can use the Q&A function to submit those. We usually give people just a little bit of typing time.
How many participants are there in today's webinar?
I'm seeing over 40 lines that are active, but sometimes groups of people call in from the same location, so we don't actually know how many people that represents.
So I'm thinking we either don't have questions or... So I would have some questions for the group. I would be intrigued to hear from definitely any clinical colleagues in the room, but anybody in general about what they think about our approach for use of vignettes and what other thoughts they might have for how to adapt the implementation we're already working with.
So, and there may be other panelists who are able to unmute themselves, or if others want to provide answers to that question. But I will say that one of the things that I really applaud was that attention to multiple chronic conditions and sort of the complexity. And it really struck me that these approaches that you're using really lend themselves to that. One question that I had for you is, it strikes me that in both of your talks, you're applying complex methodologies to a complex problem, and so I wonder if you could comment on, in terms of grantsmanship, it can sometimes be really difficult, I think, to convey what you're doing to readers, and I think both of you were very engaging speakers that were able to explain what you're doing very well, and using the slides, the visuals helped, and you made really good use of that. I find sometimes it's easier to explain things to people in that format of this nature. It gets a little harder when it's in the sort of prose of a method section, and it's hard not to make it sort of dry and it just seem hard and make your reviewers' head hurt. So I wonder if you have any suggestions or approaches for how you convey these really complex and sophisticated tools that you're using and approaches.
So I'm going to start, and then I'm sure Dr. Bhavnani is going to fill in with a whole bunch of other information. But I would say probably the most important thing from my viewpoint is to give voice to the issue. And so by that I mean, with that little vignette that I put in, when we talk about some of these, the complexity of health in general, we have to be able to bring our explanations into short little descriptions that help people understand from the clinical standpoint. So the challenge, as you put, it is definitely dealing with the methodology section and then moving into the approach. But that, from my viewpoint, it would be to have a stakeholder voice or a small vignette or on top of whatever graphic information. So
an example, a concrete example like those that you provide, even in terms of grant writing.
Yeah.
Yes. Thanks, Tim. So I have two responses to that question. It's a very important question, and I actually did struggle with it. So the two things that really helped me, the first was to really understand your reader. What does your reader know? And that comes from my human-computer interaction background, right? Know your customers, know your users. And so if the study group is going to have statisticians like what we had in PCORI, I started my PCORI, the first page of my PCORI, building on what statisticians typically do. In this case, if a regression model is not giving accurate predictions, the typical thing that a statistician does is to build a stratified model, but they pick the variable, right? They say, oh, male, female, right? Let's see if gender improves the C statistic. But in the age of big data, that's sort of a fishing expedition, even though statisticians don't call it that, right?
Right.
They'll try this, oh, we got it from some domain expert. And I argued directly to that point by saying that these a priori selection of your stratification fails in the age of big data. Because if you have thousands of variables, you don't know which one to pick to stratify a model. And so you need these more advanced methods to discover the combination of variables to find the strata in your data, the pattern, the structure in your data has to be automated. And then I showed a very small example like what Tim was saying. And in fact, the picture that I began my presentation with was on the first page of the PCORI proposal, right? This is what it's all about. And once they get that we're doing automatic stratification, then everything else sort of rolls out, right? Because then it's more details. But you have to grab their attention on the first page with the picture. So that was the first thing. I understood who the audience was going to be and then pitched the first page directly to that audience. The second thing was that I never assumed that my reader understands mathematics. And so I always stated in English first what the intuition underneath a particular formula is. And then you stick the formula as secondary, because that's not the whole point, right? The point is not the formula. The point is, what is the formula trying to do? And so I spend a considerable amount of time thinking about the intuition underneath the mathematics. And that's why we've got over 7 international awards in all, wherever we present this, is because it connects with your intuitive understanding of what's going on, instead of just, impressing them with the mathematics, which in the biomedical world doesn't work. It may work in computer science, but it doesn't work in an applied field like this. And so those are the two things. Those are the two strategies that I use quite consistently. Does that help?
Yeah, that does help. Thank you. Yes, that was very clear. And
well, people could send both of us emails. If you just type my name in Google, you will find my lab. I have a lab which is the Discovery and Innovation through Visual Analytics. My email is on my contacts page. We love to collaborate in different capacities. So if just send us email and we can have discussions on your data and how these methods can be applied.
Well, thank you. That's very kind of you to offer that. And with that, I want to just thank you both for your talk. I think with that offer, perhaps we can if there are any further questions, people might take you up on that. And I just want to thank everyone for attending the webinar today and remind people that the recording of this webinar does get posted soon on the Aging Initiative website. It may be early next week, given that we're at Friday afternoon. And it will be linked in the chat. Let's see, it's on the Aging Initiative website and then linked. So as you sign off, you'll also be prompted to complete a very brief survey, and we will ask you, if you wouldn't mind, to just take 45 additional seconds to complete that survey. Thank you to everyone, and especially to our speakers, and please have a great rest of your day.